next we'll transition in to pre-harvest water. So we talked about post-harvest water. Microbial quality standard is 0 or no detectable generic E. coli in those water sources. That's not the case for pre-harvest agricultural water. So here we'll touch on some of the risk hierarchy with different sources of irrigation water, how different types of irrigation deployment can impact potential food safety risks. So we'll go ahead and get into it here. These are some examples of production out west. So I think we have maybe some more diverse mechanisms of irrigation in California compared to some other regions. But I think the general concepts that I'll present today, they're going to apply really across the board. And so the first thing you need to figure out is determining whether or not you actually have agricultural water that you're using. So again, agricultural water is defined as water that is contacting the edible portion of the crop or a food contact surface. So I'll just go back one slide to highlight some examples of this. So this picture here, this is a furrow irrigated tomato field. So you can see the irrigation water here running through the trenches. And here are our tomato plants. So the tomato fruits would be up here, not directly contacting this irrigation water. So under FDA's definition, that would not be considered agricultural water that we need to closely monitor the microbial quality of, because that water's not directly contacting the edible portion of the crop. Similarly, this is a walnut orchard, and you can see this is a flood irrigated orchard. Maybe not the most sustainable practice, but we do still see some flood irrigation here in California. The walnuts are up here elevated in the canopy, not directly contacting that irrigation water. So again, this would be a scenario where this is not considered agricultural water, where we have to closely manage the microbial water quality. And then just in contrast, really anytime you have overhead aerial irrigation, those are going to be the scenarios where you probably do have agricultural water on your hands and need to be very closely monitoring the microbial quality. So here's an aerial irrigated field of romaine lettuce, some strawberries and onions here. So in these cases, the irrigation water used would be considered agricultural water under FDA's definition, and we'd have to manage the quality of that water. And so it can get really tricky actually to figure out whether or not the water that you're using is considered agricultural water, where you need to closely monitor the microbial quality. So in this example, this is from the Produce Safety Alliance's training. We have carrots that are irrigated through drip irrigation. Carrots are a type of covered produce, meaning we have to manage the food safety of these commodities. And then through drip irrigation, the edible portion of this crop is the roots. So even though we're drip irrigating here, that water is going to be contacting the edible portion of the carrot, the root. And so in this scenario, this would be considered agricultural water. And so I won't spend a lot of time here talking through the regulation, but currently as the rule stands, FDA has defined what is adequate sanitary water quality for pre-harvest water. And so they've set these microbial thresholds, so 126 generic E. coli per 100 ml of water as kind of the dividing line between what's acceptable, what's not in terms of sanitary water quality. So if you test your irrigation water source and you have more than 126 generic E. coli in that water, then you have to implement some sort of mitigation strategy to reduce potential risk. Also, under the current rule, FDA defines the number of times per year you have to test every single source of pre-harvest water you're using on your farm. And because of the very stringent testing requirements and the difficulty sometimes in meeting these microbial water standards, the FDA has now published a new proposed rule that really puts it on the farmer to determine what is adequate sanitary quality for their water. So under the proposed rule, the grower would have to go through this agricultural water risk assessment where they determine what are the potential risks associated with my pre-harvest water, including its distribution system and the types of crops that I'm growing, and then make a determination on how to manage that risk. There are some exemptions to that assessment. One is if you're using groundwater. So if you're using a well water source, for example, and you test that water and you have no detectable generic E. coli, then you don't have to do that assessment. You do, of course, have to do a test of your well water to make sure you meet that criteria. You're also exempt if you use a public water supply. So if you're using municipal water, you would have to get documentation from the municipality once a year that their water meets the potable drinking water standard. You can also have an exemption from that ag water assessment if you treat your ag water. So there's different ways that you can treat your water pre-application in the field and would be exempt from that water assessment. And so I'll just go through some of the different factors that have to be considered as part of this agricultural water assessment, but it's really on the growers to identify the hazards associated with their pre-harvest water and then evaluate how different factors would impact the microbial quality of that water and implement different mitigation strategies to manage those risks they've identified. So the different factors to consider we'll go through here in a minute are the agricultural water system itself, the water practices, so how you're applying that water, crop characteristics, and environmental conditions.